Here is a question that surprises most people. In a world racing toward electric vehicles, diesel engines are not disappearing. They are thriving. Diesel-powered trucks still move more than 70% of all freight on the roads in the United States alone. And globally, the numbers are even higher. So what does diesel have that electric still cannot match? The answer comes down to several interconnected advantages that reinforce each other and which will take decades to fully displace. The first and most fundamental advantage is energy density. A kilogram of diesel fuel contains roughly 46 megajoules of energy. The best lithium-ion battery packs available today hold around 1 megajoule per kilogram. That is a 46-to-1 difference. For a truck carrying 25 tons of freight over 500 kilometers, that gap is not a minor inconvenience. It is the difference between a truck that can do the job and one that structurally cannot. Consider a specific example. A modern long-haul truck with a diesel engine carries around 900 liters of fuel. That gives it a range of roughly 3,000 kilometers without stopping. An equivalent electric truck at today's battery energy densities would need a battery pack weighing close to 20 tons just to match that range. But the truck's entire legal payload is about 25 tons. The battery alone consumes 80% of the available cargo capacity. There is almost nothing left to carry. The economics collapse entirely. Diesel engines have also become remarkably efficient. The best modern heavy diesel engines convert around 45% of fuel energy into useful work. That figure is better than most petrol engines and surprisingly competitive with hydrogen fuel cells in real-world conditions. Common rail direct injection systems operate at pressures of over 2,000 bar, atomizing fuel into a fine mist that burns more completely than older injection methods. Turbocharging and intercooling force more air into the cylinders, allowing more fuel to burn per stroke. Variable geometry turbines adjust their blades to optimize airflow across the entire rev range. Some engines use cylinder deactivation to improve economy on lighter loads, shutting off cylinders when full power is not needed and reactivating them in milliseconds when demand rises again. On emissions, the situation is also more nuanced than many assume. Critics often associate diesel with black smoke and high pollution, but modern engines equipped with diesel particulate filters and selective catalytic reduction systems, which inject a urea-based solution called AdBlue into the exhaust stream, cut nitrogen oxide emissions by more than 90% compared to engines from the 1990s. Particulate emissions have dropped by a similar margin. Today's diesel trucks are dramatically cleaner than those from a generation ago. Infrastructure remains another decisive advantage. Diesel fuel is available at truck stops across every major freight route on Earth. A driver refuels in 10 minutes and continues for another 1,000 kilometers. The charging infrastructure for electric trucks at the scale required simply does not exist yet. Building it would require massive investment in grid upgrades, thousands of high-power chargers capable of delivering megawatt-level power, and years of construction across remote corridors where trucks travel daily. That investment is happening, but unevenly and at a pace far slower than demand would require. Fleet operators also look carefully at the total cost of ownership over 10 years. A diesel truck currently costs around $160,000. An equivalent electric long-haul truck costs between $300,000 and $400,000. Even accounting for lower fuel and maintenance costs over time, the payback period for electric trucks in long-haul applications stretches well beyond what most fleet operators consider acceptable. Torque is critical as well. Diesel engines produce enormous low-speed torque. A typical long-haul diesel delivers around 2,500 Newton-meters of torque, often peaking below 1,000 revolutions per minute. That pulling power is exactly what moves heavy loads from a standstill, climbs steep gradients fully loaded, and maintains highway speeds without constant downshifts. Electric motors also produce strong low-speed torque, which is why they work well for urban delivery trucks on shorter routes. But scaling that torque to multi-axle heavy freight over thousands of kilometers, while managing heat accumulation and battery degradation under sustained high load, is a fundamentally different engineering challenge. Maintenance and long-term reliability complete the picture. Modern diesel truck engines routinely run for 1 million kilometers before requiring a major overhaul. They can be serviced with widely available parts almost anywhere in the world. The global network of diesel mechanics, tooling, and spare parts has been built over decades of manufacturing scale. None of this means diesel will dominate forever. Battery energy density is improving. Charging infrastructure is expanding. Hydrogen fuel cells are emerging as a possible solution for long-range heavy freight, generating electricity onboard from a fuel tank rather than storing it in a heavy battery. These technologies will gradually take market share, particularly in regional and urban applications where range requirements are lower. But for the decade ahead, diesel engines will continue to move most of the world's heavy freight. Not because the industry is resisting change, But because the physics of energy density and the realities of global infrastructure still favor the technology that has been refined over more than a century of engineering. The transition is coming. It is just arriving on a timetable shaped by physics, not just ambition.